Hi, this is Neville Douglas from Ashanti Dutch Property Letting. It is the 31st of March. I always get this. 30th, 2019. So much stuff going on in my head. Right, okay. The other thing that we're going to look at today, very quickly, is once again calibration part 2. This is looking at a thermal imaging camera. Okay, so I'm going to show you the camera. I'm going to show you how you. I'm not going to go into how you should calibrate it. Once again, these are the questions that you should ask if someone turns up with a thermal camera and they are going to do a thermographical survey of your building. And what you're looking at, we're going to look at a thing called emissivity. Wow, I got that right the first time in ages. And this is basically the reflectiveness of the materials around you in regards to radiant heat. Okay, that's what the thermal imaging camera picks up on. And this should be calibrated, so I'm going to go through very quickly what you need to do to calibrate the camera. I'm not going to show you how to do it, I'm just going to tell you about it because it's a long process and you need to have been trained. I've done a level 1 thermography course, or a Cat 1, Cat 1, I'll slow up a little bit. It's a category 1 thermography course so that I can be a category 1 thermal imaging assessor. Wow, what a mouthful. So now I've got that out of the way. Basically, it's a very intensive course. It shows you how to set up your camera and how to use the camera. So, and the checks that should be done before the camera is used in a particular environment. So, switching around, this is my camera. It is a FLIR E6. So when you first start using the camera, I'm just going to get that out of the bag for you. Okay, it does internal checks and it calibrates itself. Before you use a camera, what they should do is, like I said before, I'm just going to spin the camera around again, is they should be calibrating the camera to the environment. So when they come into your environment, the camera should be calibrated to see if there's any reflected, emitted or absorbed heat. And the way that they do this to get the apparent, because when they first use a camera and they take a photograph when they first come to the camera, if they take it from the outside, they're taking all of the sky, the reflectivity of the sky, the reflectivity of the materials around them, which is lights, work surfaces and everything else. So what they should do is to set the, I think it's called the apparent temperature, okay, or the temperature. There is a setting. Let me just go back to the camera and I'll show you what the setting is. So we'll go on to here, I don't know if you can see that okay because the screen's a bit blue. You go into settings, which is over here, and then you go into measurement parameters, and they should go into the emissivity, which has to be altered, and the reflective temperature. Okay, so I don't know if you can see those settings there. No, you're not going to get much joy with that. Okay, so the things which have got to be set is the reflective temperature, and also they have to thermally tune the camera, which means not using it on automatic mode and using it on the manual mode. So if they're just clicking the camera and you're getting all these images that look great on the internet, you can see them, you can tell that they've not used any of the palettes and they've not tuned the camera to your particular environment. Now that's great if they're just doing an overall assessment and they're trying to pick up on the warmth and the cold. So you need to ask them if they are doing a qualitative or a quantitative research, okay? So you know what to expect from them. Right, so going back to calibration, what you do is you get the reflective temperature, which comes from using an item like this, which is foil. You can see all the lights reflecting off it, and that's what you use. You would use that then to set your reflective, what's the word I'm looking for again? Reflective temperature, sorry. So you'd use that to set your reflective temperature. And then the other thing, what you would then do is you would then do calibration using this, because obviously this is reflective. So this is what's known as the emissivity. What a word. Emissivity. Okay, so basically this is how much this is reflecting compared to how much this is not reflecting. Now with the tape, there's a liquid in there and it's just water, and I've got a thermometer in here. Also, if they're going to do the calibration, make sure that they've calibrated the thermometer as well. So they should put on the report the temperature that was recorded. If you look at this, it is 63.6 degrees there. Okay, now you can use something like this, which is an infrared digital thermometer. Okay, now if they're going to use something like this, this needs to be calibrated as well. So if I use this digital thermometer, and this one can be calibrated with the relative humidity of the room as well, so you need to check if they are checking their equipment, is the equipment that they're using for their tests done. So as we just saw, that was 63 degrees over there. Okay, and we come back, and if we use this now, switch it on, press that, and you point that at there, you can see a laser, and you can see the 2 points of the laser. Let me just go in there. You can see that on the jug. I'll do it on the black tape so you can see the, as I get closer, there we go, you can see the 2 points of the laser converging. If I pull it a bit away for you, you can see that the 2 points are not converging, which means it's at the wrong distance. So once we get close enough, look at the temperature reading on that. It says it's 55, 56, because my hands are shaking a little bit, 56 degrees. Now we've confirmed with the thermometer that it's actually 62 degrees. So there's a difference there, okay? So now if we do it on the stainless steel container, it's showing 30 degrees, 31 degrees. And that's just from moving from one side to the other, because this is reflecting a lot of the heat, and it's reflecting the environment in here. So basically, it's not going to give you a true reading of what the temperature is. Let's say, for instance, you wanted to do a qualitative survey, so you wanted to find out if a component was overheating or something like that. That wouldn't really be accurate, so you'd have to put something on there to mask the reflection, so that one could then allow the heat which is in there to be transmitted out of the container into the camera. Hope this isn't too technical for you. Now I've got a tea light under there, keeping that water at a constant temperature, because you need a constant temperature to be able to calibrate your camera. So what you do is you calibrate your thermal camera so that so that it reflects the true, or as close to, the heat reading on there and on there, and that way you adjust the emissivity of the thermal camera so that that reading and that reading are the same, and then that will give you the temperature of that, which is the temperature, which is 61 degrees. So it's quite a long process. The other thing in regards to reflection, if you look here, right, I've got that on the stainless steel container. Can you see on the table there? You've got reflective heat. You've got reflective, the laser is reflecting. Now, this is common, right? And that is reflection. So if you're going to try and get a reading from something with your thermal imaging camera, you have to realize that you are going to be picking up on the reflection from all the surfaces. So even though the surface, you can see the laser there from the camera, from the thermometer. I'm going to slow up. Okay, so even though you can see the lasers there from the laser thermometer, okay, it works the other way around as well. So the surface is reflecting on the stainless steel, and that's going to affect the readings that you get. So this has got a certain amount of heat, even though it might feel cool, but it's not. It's what's known as ambient, so it's at room temperature. So the room temperature of this item is going to be reflected on there. So if the fluid in there was cooler, you would find that you would be getting warmth from this material reflecting onto this, the same as if you've got any lights, or you've got timber, or you've got candle underneath which is keeping it warm and everything else. You're going to get reflective heat as well. So that's why the camera has to be calibrated to that, and then to that, and then the temperature checked, and then it comes all the way around to here. Now, if all of that I just said makes your brain hurt, my brain is hurting too. So basically, what I'm saying to you is, when you get someone round with a thermal imaging camera and they are going to do any work for you, just ask them how they calibrated the camera and what kind of survey they're going to do for you, if it's qualitative or quantitative. Qualitative means just to find where there are cold spots, but there's a bit more to that as well, and I can't go into that at the moment. And qualitative quantitative, sorry, means that they are going to give you temperature readings and they're going to monitor the environment for you. So these are the things that you need to be aware of. I'm going to finish calibrating my camera, and also you need to ask them for certificates as well of when the equipment was calibrated. Most of it should be calibrated every year, and they might say it's not important, but it depends on what your survey is going to be used for. So sorry this was a little bit technical. This is Neville Douglas from Ashanti Dutch Property Letting signing off.